All right, we are almost at the end. Okay, these are the notes for day 13, um, and we're going to cover 5.3 and 5.4 in kind of three parts today, right? Because you did part one yesterday, and then also finish with 5.1. Okay, we're going to look at perpendicular bisectors and altitudes and medians, and here we're going to start with an example one. Determine the equation of the perpendicular bisector of the triangle ABC given the coordinate points with base AB. Now that's important there with base AB because that's the side of the triangle that's going to be bisected. Okay, so we kind of broke it down for you here in steps. Hopefully it's easy to follow along. Um, we first need to figure out the slope of AB because if we can figure out that slope, then we can figure out the perpendicular slope, right? Because we need the perpendicular, okay? Then after that, since it's bisected, that means AB is going to be cut in half, which means we need to figure out the midpoint between A and B, so we're going to use the midpoint formula. So in step one, we figure out the slope of AB, right? We got to remember the slope formula, y2 minus y1 over x2 minus x1. Be careful of what you're using for x and y's, okay? And so the slope is negative 2/3. Now you gotta make sense of these problems, right? Like, why does it make sense that it's a negative 2/3? Because from A to B, it's decreasing. It's a negative slope. So you got to think about, well, if you somehow you came up with a positive, that should be a red flag, right? That doesn't make sense. Okay, so it's good that it's negative 2/3. Then the perpendicular slope is, remember, opposite reciprocal. So the negative is going to change to a positive, and the fraction is going to quote unquote flip, and so we have a positive 3/2. So I'm going to make note of that. Okay. By the way, I apologize for these little like black bars. When I take like screenshots or like a snippet, then somehow sometimes these page indicators show up. So I apologize for that. And again, midpoint formula: x1 plus x2 divided by 2, y1 plus y2 divided by 2. Okay. Turns out to be 3 comma 6. Okay. And then it says using, now we got to write the equation, right? We know the slope is 3/2, right? And it goes through the point 3 comma 6, right? That's the midpoint. It goes through that point. And so it doesn't say specifically what equation to put it in. I would say why not use the point slope equation, right? So that you have the point, you have the slope, and then we just write it in. So this is going to be y minus 6, right, equals the slope 3/2 multiplied by x minus 3, right? Remember these signs switch. Okay. Now, if you want to leave it here where I'm highlighting, that's fine. If you want to distribute the 3 halves and then add the 6 to put it into slope-intercept form, that's also fine. Okay. So this next problem is the same idea. Perpendicular bisector, okay, with base BC. If you want to pause it here and try this one on your own, rewind it and then try it. That would be good. Okay. It's another one, perpendicular bisector again. Okay. You got to make sure that you know how to do these. All right. As we go into day 3, we're going to look at altitudes and medians, but we're going to start off with a proof here, right? Remember, an altitude comes from a corner of a triangle to the opposite side and creates 90 degrees. Okay? It doesn't cut the side in half, not all the time, but the word altitude implies that it creates 90 degrees. Okay, and so you're given this angle, right? CFD is congruent to EFD, so we put tick marks here. You're given that FD is an altitude that's given. Well, if that's an altitude, then this angle here, CDF and EDF, are right angles. So if altitude, then right angles, and we know that those angles are going to be congruent, and so we declare CDF is congruent to EDF. If right angles, then they are congruent. Now I want to pause here. You have to have statement 3. You can't jump from statement 2 to statement 4. Okay? And so you have to state in 3 that they are right angles first. Okay? And then after that, we know that DF is congruent to itself, DF, by reflexive property. And by angle side angle, line 6, these triangles are congruent. Okay? Now we're trying to show that FD is a median, which means that CD has to be congruent to ED, right? And we know that's true in statement 7 because of CPCTC, right? Again, we prove the triangles are congruent, so all the corresponding parts are congruent. And if those are congruent, then that must mean that FD is indeed a median, right? If there are 2 congruent segments, then FD is a median. Okay. Take a look at this proof, all right? Hopefully you can follow the logic, all right? Now it says finding, in this one, you're given the 3 points to make a triangle, right? Now it says find the equation of the median from C to AB, right? Now, here's the thing, right? Median is from a corner of the triangle to the midpoint of the opposite side. So that means, see here in step 1, right? Part A asks to find the equation of the median. So we need the midpoint of AB, which we do here. It's at 3, 3. We need the equation using the midpoint and point C, right? This red line, this is the equation we're trying to come up with, right? If I know, I got to figure out the slope, right, from C to this point, right? So between 3, 3 and 5, 12. And so we know that here, by the slope formula, it's 9/2. Okay? So why do we have 2 options here? Because you can use either point, right, for the equation. You can use the midpoint, or, excuse me, you can use point C, all right? Doesn't matter which one. Part B says, find the equation of the perpendicular bisector of AB. So we know that it cuts AB in half. We need to figure out the slope of AB so that we can figure out the perpendicular slope. Right? The slope of AB turns out to be 1/6. So the perpendicular slope is -6, which is here. We know the midpoint of AB is 3, 3, and so that's what we're going to use with the slope right here. Okay. Now from C, in part C here, I'm going to do a little some scrolling here. It says to find the equation of the altitude from C to AB. Right, this is the yellow line. Okay, and so we need the slope of AB. All right, the altitude is perpendicular. Okay, all right, so it runs parallel to C actually. Okay, and it says write the equation using the perpendicular slope and point C, because now there's a point here on AB, right? But we don't know where that is. Okay, but we do know that it runs through C, so why not use the point C, 5, 12? All right. Okay, these are some more of the same problems. Okay, you can go through these examples and note solutions on your own carefully. Same thing with this one. Okay, doing altitudes. All right, find the orthocenter. Right, this is a systems problem. Okay. Some more of these. Find the median. Okay. Median is the halfway on the side here. All right, and again, need to use a system of equations. Okay, and a perpendicular bisector. All right. And then to end it with 5-1 mid-segments. Okay. A mid-segment is a segment connecting the midpoint of two sides of a triangle. All right. And so here, AB, B is the midpoint of AC, D is the midpoint of CE, and so therefore BD creates this mid-segment. All right. Now there's this theorem that basically says, all right, the couple things here. All right, the mid segment is parallel to the base here. Right, it's parallel. Okay, and also not only that, the length of this mid segment, in this case DE, is half the length of the base BC. All right. Or you can say that BC is twice the length of DE. Okay, that'd be the same thing. All right. And so I put examples 1 and 2 here together. All right. How do you know that it is indeed a mid-segment? You can't just assume it. I know it's a little hard to tell here, but hopefully in the notes you can tell. You got to have these tick marks, right? Like here, if you know that XA is congruent to ZA, but let's say that there were no tick marks here, right, in YB and ZB, then you cannot assume automatically that X plus 1 here is a mid-segment, okay? But that's why you need to have these tick marks. Now, in example 2, though, you don't have any tick marks. But the thing is, it tells you that FH is a mid-segment, okay? So if FH is a mid-segment, then these, the following conditions apply, right? GH is congruent to IH, all right? Then we also have this relationship, and here in red, 2 times 2x plus 3y, because if you double the mid-segment, that equals the base, right? 104, okay? And these are just some, this is attached to 5.1, all right? But these are more practice problems from 5.3 and 5.4, days 2, 3, 4, finding the equation of the medians and altitudes and things like that, right? Remember, the centroid is what you call the meeting point of all the medians, okay? And so it really becomes a system of equations problem, all right? And I believe this is the last slide, yep. Just one last proof here to finish with, okay? Prove that these triangles are congruent, right? Remember we learned about isosceles triangles. If isosceles, then the sides are congruent, and if the sides are congruent, then the base angles are congruent, all right? Here, BD is a median. You do not say that D is a midpoint, right? That shouldn't be one of your reasons. But if median, then you have 2 congruent segments. Okay. All right. So, please, if you need to rewatch this video, that's fine. Or, there's no quiz today. If you are confused on anything, please shoot me an email. And you do have a little bit of homework due later today.